Welcome children. Today we continue with chapter 4 of Geography Climate for Standard 9th, and this is the second part of this chapter. Children, today we are going to learn about the factors affecting India's climate, and there are three main factors. They are latitude, altitude, pressure and wind system. Children, before I explain to you the factors affecting India's climate, first we need to learn about certain concepts. Now these concepts are pressure belts. I'm sure you have learnt it earlier, but we need to revise them. It's pressure belts, the permanent winds, the Coriolis force, the jet stream and ITCZ. Now children, let us understand what is Coriolis force. So as you know, the earth spins around its axis and it spins from west to east and a force is generated. Now this force is called as Coriolis force, which affects the direction of the winds. Now for example, to understand the Coriolis force, suppose there is a boy standing at North Pole and ask him to throw the ball at point A. So when he throws the ball at point A, it doesn't fall at point A, it gets slightly deflected and falls at point B. Why does this happen? Because of the rotation of the earth on its axis. Similarly, if he stands at South Pole and he drops the ball at A, it gets deflected towards B. This is because also of the Coriolis force, because the earth is spinning on its axis, and due to this it affects the direction of the wind. Now in the northern hemisphere, you know the equator divides the earth into two hemispheres, northern hemisphere and southern hemisphere. In the northern hemisphere, the winds get deflected towards the right, and in the southern hemisphere they get deflected towards the left. Okay, so this is caused by the Coriolis force. It is also called as Coriolis effect, and this is due to the earth spinning on its axis, which is generating a force and affects the direction of winds. Now children, let us understand what are pressure belts and wind system. So children, all of you know that the equator divides our earth into two hemispheres, northern hemisphere and southern hemisphere. Children, all of you know that our earth is surrounded by a blanket of air, which is called the atmosphere. And why is the atmosphere around the earth? It is due to the gravitational pull of the earth. So this air has weight and it exerts pressure on our earth's surface. Okay, and as you know, air is not constant, it is continuously moving, and the main difference in air pressure is caused by difference in temperature. Now due to the spherical shape and the rotation of the earth, the different parts of the earth are heated unequally, enabling belts of low pressure and high pressure. So you can see the direct rays of the sun are falling on the equator. So this area gets heated up. Okay, it's very hot. Whereas you see, as we move away from the equator, they are getting slanting rays of the sun. So this is the unequal heating of our earth's surface due to the rotation and the spherical shape of our earth. So children, the equatorial region receives the direct rays of the sun. Okay, and which is the equatorial region? Equator, Tropic of Cancer and Tropic of Capricorn. This region gets the direct rays of the sun, so this region becomes very, very hot. Now children, you must remember this: whenever the temperatures are high, pressure is less. So this region becomes a region of low pressure. Now children, this is an inverted image of our earth. You can see this red line is the equator. This region gets hot. So here the air becomes hot and hot air rises, goes up to the troposphere. Okay. Now children, this is an inverted image of the earth. You can see this red band is the equator. Just to show you how the hot, now from here, because this region gets hot due to the direct rays of the sun, the air becomes hot and hot air rises. It rises and then it deflects into two parts. You can see because of the rotation of the earth. So when they go up, they meet the colder air from the poles. They cool and start to descend at 30 degrees north and south of the equator. So children, here you can see that the warm air at the equatorial low pressure belt rises, and then it rises up and cools by meeting the cold air coming from the polar regions. It cools and becomes dense and then sinks down on the earth and forms a belt of high pressure belt called the subtropical high pressure belt between 30 and 35 degrees north and south of the equator. Now children, at 60 to 65 degree latitude we have a belt of low pressure, okay, because the winds blow from high pressure to low pressure, okay, and the winds are then made to rise, and due to the rotation of the earth, the winds get deflected and creating an area of low pressure. So this area is called as a subpolar low pressure belt between latitude 60 to 65 degrees north and south of the equator. Now children, at the poles the sun's rays are slanting, so they hardly get any sun rays. They're much inclined, you can see, so this region remains cold, so the air here is dense, and this region is a region of high pressure belts. So you see, due to the unequal heating, it enables the belts are created of high pressure and low pressure. So we have alternate high pressure and low pressure belts on the earth. Starting from the equator, it is low pressure, then high pressure, then low pressure, and again high pressure belts. Now children, this is a diagram showing the pressure belts of the world. There are 7 pressure belts. You can see it's equatorial low pressure belts lying between 10 degree north and south of the equator. Then we have the subtropical high pressure belts between 30 and 35 degree latitude, both north and south of the equator. Above that we have the subpolar low pressure belt between 60 and 65 degree north and south of the equator, and then at the poles we have the polar high pressure belts, okay, both at north pole and south pole. Okay, so we have total 7 pressure belts. So all of you know how the equatorial low pressure belts are formed because of the direct rays of the sun. Here the air gets warm, the warm air rises, and then it cools while meeting the winds coming from the polar regions. It cools and descends at the region of 30 and 35 degree, creating a region of subtropical high pressure belts. Okay, this region is also called as horse latitude. Now when the travelers earlier, when they would travel from the equatorial low towards the subtropical high, they would carry horses and cattle at that time, and little did they know, because it's a high pressure belts, they could not speed up their boat, so they would just throw the horses into the sea just to make their boat light. Okay, and that is the reason why it is called as horse latitude. Now winds, when they blow from subtropical high towards the polar region, and due to the rotation of the earth, a low pressure belt is created, which is called as the subpolar low pressure belt between 60 and 65 degrees north and south of the equator. And as you know, polar regions are absolutely frozen with ice, so the air here is dense, and that is why this is a region of high pressure belt. Now children, let us understand the wind system. The horizontal movement of air is known as wind, and children, remember, air always blows from high pressure to low pressure. This you have to remember always. Wind blows from high pressure to low pressure. The wind is given a name from the direction from which it blows. The wind that originates from the western side is called west wind or westerlies. So if they're blowing from the west, they'll be called as westerlies. If they're blowing from the east, they'll be called as easterlies. Now the winds that originate from the south are known as south winds. You can see in the diagram, they're originating from the south, they're called as south winds. If they originate from the north, they're called as north winds. Now let us understand what are planetary winds or permanent winds. Now these winds blow constantly in a particular direction throughout the year. Let us see the important permanent winds. Now children, this is a diagram showing the permanent wind system. Okay, now you can see, as I have already told you, wind blows from high pressure to low pressure. Now let us look at this high pressure belt. In the southern hemisphere, you can see subtropical high pressure belts moving towards equatorial low pressure belts. Similarly, in the northern hemisphere, you can see subtropical high pressure belts. The winds are moving towards equatorial low pressure belts. Okay, now when in the northern hemisphere, as you know, the winds get deflected due to the rotation of the earth. So in the northern hemisphere they blow towards the right, and in the southern hemisphere they blow towards the left. Now here you can see winds from the northern hemisphere, the subtropical high pressure belts, when they blow towards the equatorial low, they blow from northeast. Okay, they blow from northeast, so they are also called as northeast trade winds. And when they blow from the southern hemisphere, from the subtropical high pressure belts towards the equatorial low pressure belts, they blow from southeast, so they are called as southeast trade winds. Okay, now again you can see here winds are also blowing from subtropical high towards subpolar low pressure belts. Okay, and in the northern hemisphere they blow from southwest, so you can see southwest, and in the southern hemisphere they blow from northwest. So since they're blowing from the west, they're called as westerlies. And then if you go up, you can see from the polar high pressure belts, you can see winds blowing from the polar high pressure belts towards subpolar low pressure belts. In the north they blow from northeast direction, and that's why they are called as polar easterlies. In the south you can see they are blowing from southeast direction, and because they are blowing from east, they are called as polar easterlies. So basically, what are the permanent winds we have? We have southeast trade winds and northeast trade winds. We have southwest westerlies and northwesterlies. Okay, and then we have polar easterlies, both north and south. Okay. Now children, let us understand another concept called intertropical convergence zone. It is also called as ITCZ. Now children, all of you have studied the pressure belts of the world, and all of you know the equatorial region is a low pressure belt because it receives the direct rays of the sun, and here the air becomes hot and it rises, creating low pressure belts. So winds, as you know, always blow from high pressure belts towards low pressure belts. So in the northern hemisphere they will blow from subtropical high pressure belts towards equatorial low pressure belts from the northeast. That's why they are called as northeast trade winds. Okay, and in the south again they will blow from subtropical high pressure belts towards equatorial low pressure belts from southeast. So they are called as southeast trade winds. So children, when these northeast trade winds and southeast trade winds, okay, when they come towards the equatorial low, they come together and converge. Okay, they come together, and that creates a zone of intertropical convergence zone. So there is red band you see is the intertropical convergence zone, where both the northeast easterlies and southeasterlies meet at the equator. This whole region that encircles the earth is called as the ITCZ zone, intertropical convergence zone. Now children, let us have a look at the position of the suns on the following dates. On 21st March we can see that the sun rays falls on the equator. Okay, and then as the earth revolves around the sun. On 21st June we see the sun falling on Tropic of Cancer. On 23rd September again the sun rays falls on the equator, and as the earth revolves around the sun, on 22nd December the sun rays falls on Tropic of Capricorn. So you see children, the ITCZ zone shifts when the sun is shining at Tropic of Cancer on 21st June. This ITC zone shifts towards Tropic of Cancer. Again on 21st March and 23rd September the sun shines at the equator, so this ITC zone shifts towards the equator. And then on 23rd December when the sun is shining on Tropic of Capricorn, the ITCZ shifts towards Tropic of Capricorn. So we see the shifting of the ITCZ zone. And what is ITCZ zone? Intertropical Convergence Zone. Another concept that you need to understand are jet streams. Now, what are jet streams? Jet streams are narrow belts of high-speed westerly winds which blow in the troposphere. Now, confusing, isn't it? Now, just all of you know that there are layers of the atmosphere. The first layer is the troposphere. Now, there are high spins which are flowing. Okay. Now, let us understand this in a simple way. The sun's rays doesn't hit the whole earth evenly. That is why the areas near the equator are hot and the areas near the poles are cold. So you can see at the equator the air becomes very warm, and as you know, warm air rises, it rises and meets the cooler air coming from the poles. Okay, and so as you know, as it cools they start to sink back to the earth. Okay, but all of the air doesn't sink back to the earth. Some remains up in the troposphere. Okay, and these are called as jet streams. So we have jet streams at 30 degrees north and also a jet stream formed near the poles at 60 degrees north. So there are polar jet streams and subtropical jet streams both in the north and south of the equator. So jet stream is a type of air current that forms high in the atmosphere, and they are narrow bands of strong winds that generate from west to east, because our earth rotates from west to east. So they also generate from west to east and flow all across the globe, all around the earth they are flowing, and in a zigzag manner. Now why in a zigzag manner? Okay, because here you see there are bands with the cold air makes it descend, then from the hot air from the equator makes it goes up. So they are moving in a meandering manner. Okay, and there are two types of jet streams. One you can see at the poles, they are called as polar jet streams, and the one at 30 degrees they are called as subtropical jet streams. So both north and south of the equator, and they move at great speed, almost 110 miles per hour. And this happens because of the difference between warm and cool air masses cause these jet streams to move at a high speed. Okay, very high speed. That is why it is called streams, like the river flows, but jet streams, like the jet flies at a very high speed. That is why this name is given as jet streams. Now children, one thing you must note, that because the ITCZ, the intertropical zone, shifts from the equator to the Tropic of Cancer and Capricorn, now along with the ITCZ the pressure belts also shift, and so also the winds and also the jet streams. Okay, they keep shifting. Now let us understand how latitude affects the climate of India. Now children, let us revise the important latitudes. All of you know 0 degree latitude is the equator, then 23.5 degree north latitude is Tropic of Cancer, and 23.5 degrees south latitude is Tropic of Capricorn. And this region between the equator and the two tropics receive the direct rays of the sun. So this region is very, very hot, and they have a tropical type of climate. Okay, and as we go above the tropics, they receive slightly slanting rays of the sun. So this region, both north and south of the equator, the blue one that you see, is neither very hot nor very cold. So it is a moderate type of climate there. So that is the subtropical region. Now let us have a look where India lies. Now children, you can see the latitudes which are crossing through India. It's between 8 degree north to 37 degree 6 minutes north. And you can see 23.5 degree north, that is Tropic of Cancer, is almost crossing our country and dividing a country into two halves, isn't it? So which are the states where this Tropic of Cancer is passing through? It is Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura and Mizoram. So here is another map which shows the Tropic of Cancer passing through India. It starts from Rann of Kutch, ends at Mizoram. So you can see the Tropic of Cancer has divided our country into almost two equal halves. Now children, you can see where India lies on which climatic zone. You can see here we are in the North Torrid Zone, okay, and then half of India is in the Torrid Zone and half is in the Temperate Zone. So we'll understand the type of climate. So children, here you can see that the Tropic of Cancer passes through the middle of our country, right from Rann of Kutch in the west to Mizoram in the east. And so almost half our country lies south of the Tropic of Cancer, which is the tropical region, and the remaining half in the north lies in the subtropical region. So the tropical regions remain hot, whereas the subtropical region is less hot. So India's climate has the characteristics of both tropical as well as subtropical climate. Children, let us go to the next factor that affects the climate of India, that is altitude. Now this is a map of our country. You can see we have the mountains, we have the plains, plateaus and the coastal region. And the coastal region, the maximum elevation is 30 meters. Now towards the north we have the Himalayas. Okay, you can see the Himalayas ranging from northwest to northeast, and they have an average height of 6,000 meters. Now this Himalayan range you can see here, which right from northwest to northeast, this blocks the cold chill winds coming from Central Asia and Siberia in the north. And owing to the mountain, due to this mountain, our subcontinent experience milder winters as compared to Central Asia. Now the third factor that affects the climate of India is pressure and winds. Under this we are going to learn three different topics. They are pressure and surface winds, upper air circulation, western cyclonic disturbances and tropical cyclones. Now let us quickly revise what is pressure and winds. Now pressure, as you know, the earth is surrounded by a blanket of air called atmosphere, and the pressure exerted on the earth by this air is called as air pressure or pressure. Okay. Now the next thing you must know, what is low pressure. When temperature increases, the air becomes hot enough to rise above and thus creates a zone of low pressure. And high pressure is just the reverse. When temperature decreases, okay, the air becomes cold enough to sink. Because it is dense, it sinks and creates a zone of high pressure. Now let's see what are winds. The horizontal movement of air from high pressure to low pressure is called as winds. Okay, and the climates and the associated weather conditions in India are governed by the following atmospheric condition. One of them is pressure and surface winds. Now children, as you know, India lies in the subtropical high pressure belt. You can see here, this is the belt. So which winds originate here? The northeasterly winds originate here. This is a map of India, and you know that India lies in the subtropical high pressure belts, and winds, or you know, that blow from high pressure belts towards low pressure belts. So the which winds originate here? The northeasterly winds originate here in the subtropical high in the northern hemisphere, and they are blowing towards the equatorial low pressure belts, because they blow from high pressure belts to low pressure belts. But do they blow straight like this? Do they come in straight? What happens to these winds? So you see, these northeasterly winds actually don't come in straight towards India. They get deflected. Now why do they get deflected? As I have already told you, due to the Coriolis force, and Earth is rotating, and due to this force it is exerted on the winds, which gets deflected towards the right in the northern hemisphere, and these northern easterly winds originate from the northern hemisphere, so they get deflected towards the right and they move towards the equatorial low pressure area. Now these winds, the northeasterly winds, carry very little moisture as they originate and blow over the land. They're coming from the land, okay, and therefore they bring little or no rain, okay. Which winds bring in moisture? Only the winds which blow over the ocean, so they carry moisture. But so according to this, India should have been a complete desert, because it is not bringing any rain to India. But this is not what happens, okay, because pressure and wind conditions over India are unique. So where does the rain come from? We are a absolutely monsoon type of climate. We get enough rain. So how does this rain come? Let us look into that. So you see children, these northeasterly winds are dry winds. They don't carry any moisture, okay, and because they are blowing from the land, and they are blowing from high pressure, and that time during winter there is high pressure north of the Himalayas, and cold dry winds blow from this region towards the low pressure area, from which high pressure, subtropical high pressure, towards equatorial low pressure. So they are dry winds. They do not give any rain to India. According to this, India should have been a desert, but this does not happen, because the pressure and wind conditions over India, as I told you, are unique. The reverse happens in summers. Now children, let us see what happens in summer. In summer, a low pressure area develops over interior Asia as well as northwestern India, and this causes a complete reversal of the direction of the winds during summer. Now as you know, air moves from high pressure to low pressure, isn't it? And so now air from the high pressure area over the southern Indian Ocean, now in the southeasterly direction, now starts gathering, because there is low pressure. These winds now have to somehow occupy that space, so they move in the southeasterly direction. When they cross the equator, okay, what happens? The winds get deflected towards the right, okay, and they towards this low pressure area over the subcontinents, and these winds are called as southwesterly monsoon winds. And since these winds blow over the warm ocean, they gather moisture and bring widespread rainfall to India. Now the next factor that we will look into is upper air circulation. Now so far we have studied about the surface winds, which blow on the surface when we feel it. But there is also a type of air current that forms high up in the atmosphere, that is in the troposphere, and how that affects the climate of India. That is the jet stream. So upper air circulation, we are talking about the jet stream. The sun's rays doesn't heat the whole earth evenly. That is why the areas near the equator are hot and the areas near the poles are cold. So you can see at the equator the air becomes very warm and as you know, warm air rises, it rises and meets the cooler air coming from the poles. Okay, and so as you know, as it cools, they start to sink back to the earth. Okay, but all of the air doesn't sink back to the earth. Some remains up in the troposphere. Okay, and these are called as jet streams. So we have jet streams at 30 degrees north, and also a jet stream formed near the poles at 60 degrees north. So there are uh, polar jet streams and subtropical jet streams both in the north and south of the equator. Now, as I told you about the jet stream earlier, this subtropical jet stream blows over India. Okay, and this grows in a fast speed. You can see the zigzag manner, around 110 miles per hour it blows, and we will learn how this subtropical jet stream affects the climate of India. So children, you see this subtropical jet stream are located around 27 degree north to 30 degree north latitude. Now this jet stream, subtropical jet streams, in winter it blows towards the south of the Himalayas, below the Himalayas, okay, in winters. And in the summers, the jet stream blows over the north of the Himalayas. So you see it shifts from south of the Himalayas in winters to north of the Himalayas in summer. Now children, you must be wondering why the jet stream shifts. In winter it is to the south of the Himalayas, and in summer it is towards the north of the Himalayas. This is due to ITCZ. Now what is ITCZ? The full form is Intertropical Convergence Zone. Now here at the equator, where the winds from the subtropical high pressure belts come toward the equatorial low pressure belts, that is the northeasterly winds and the south easterly winds, they come and meet and converge. This creates a zone called the ITCZ zone at the equator. And when the sun moves towards the Tropic of Cancer, this zone also moves towards Tropic of Cancer. And when the sun moves to Tropic of Capricorn, ITCZ zone moves to Tropic of Cancer. And because of the ITCZ, there is a shift in the jet stream, there is a shift in the pressure belts, there is also a shift in the winds. Okay, they all keep shifting due to the ITCZ zone. Let us now see how the western disturbances and the tropical cyclone affect the climate of India. Now children, let us understand how this jet stream affects the climate of India. As I told you, in winters, this is winter season, where the jet stream is flowing towards the south of the Himalayas. And here you can see there's a sea called Mediterranean Sea, where the cyclones have developed and there is rainfall in the nearby areas. And the jet stream passes through this. I told you the jet stream is not only in India, throughout the globe this jet stream is flowing. It's upper air circulation. It's high above in the troposphere. Okay, and this jet stream now flows through the Mediterranean Sea. So with that force, they bring these moisture laden winds are carried over to India, and then it brings moderate rainfall in the Punjab plains and also snowfall in Himachal, Uttarakhand, Jammu and Kashmir. Now this is called as western disturbances, okay, because they are bringing from the west, they are flowing from west to east, and this rainfall is very, very useful for Punjab, especially for the rabi crop wheat. Okay. During summer, the Tibetan plateau gets heated. As a result, it creates a region of low pressure. And so this, you can see the subtropical jet stream, which was blowing towards the south of the Himalayas in winters, now shifts towards the north of the Himalayas in summer. And as they blow from west to east, they are called as westerly jet stream. Now this westerly jet stream, when they shift to the north of the Himalayas, they get replaced by easterly jet stream, and this easterly jet stream then blows over peninsular India around 15-degree latitude during summer, and this creates tropical cyclones during monsoons as well as in October and November, and also helps in the sudden onset of monsoons. Now this easterly jet stream brings cyclonic rainfall in the eastern coastal region of India during the monsoons as well as during October and November. You can see a depression is created in the Bay of Bengal, bringing cyclonic rain in the east coast or coastal region of India. So children, with this we complete the second part of this chapter, and very soon I'll be coming up with the third part. Till then, do view and subscribe. Thank you.